Hello and welcome. Just the other day, we were doing integration techniques, and I came across an interesting question. One of my students asked, is there something wrong with my MF26? Now, what propelled the student to say that was because if you look at page 4, and if you look at some standard integrals, you might notice that on the right-hand side over here, there is a pattern. And that is, if you look at the tangent inverse, right, there is a 1 over a in front of it. For natural log, there's a 1 over 2a. But for sine inverse, there is no constant over here. There's no 1 over a. So the student said, oh, I think there's something wrong with my MF26. There should be a 1 over a in front of the sine inverse. To which I quickly assured the student, no, there's nothing wrong with your MF26. Okay, let's find out why there is no 1 over a over here. Now, before we do that, first I'm going to make use of some standard results from page 3, and that is the derivative of tangent inverse is this, and the derivative of sine inverse is this. Okay, let's take a look. Let's start with the derivative of tangent inverse over here. Right. Now, I'm going to do some kind of substitution, and that is I'm going to let u equals to x over a. You might ask why. That is because the form that we are given in MF26 on page 4, if you look at the argument of the tangent inverse function, it is x over a. And that's what I'm trying to show. I'm trying to show you that if I differentiate this thing, I will be getting this. Yeah? And similarly, if we differentiate this, we'll be getting this. Okay, so there's nothing wrong, huh? Oh, so let's go back to tangent inverse. So if I let u equals to x over a, naturally, then du dx is just 1 over a. Then I can also say that, hey, if I d dx tangent inverse u instead, then this would be actually equals to the derivative of tangent inverse times the derivative of u. This is chain rule. Yes, differentiate the outside, then the inside, or the inside and outside, whichever way you want. Okay, so next I'm going to substitute back u is just x over a. So now this is starting to look like the form that we see in MF26, tangent inverse x over a. Now on the right hand side, I also made a substitution. U is equals to x over a, so u square is x square over a square plus 1, and then du dx is 1 over a over here. Okay, so for the right hand side, not quite what we are looking for, because what we're given is actually x squared plus a squared. So I want to make this denominator x squared plus a squared. How I can do that is to multiply by a squared to the denominator and the numerator. So that's what I did. Multiply by a squared here, multiply by a squared here. Okay, then you notice that, hey, there's an a squared here and there's an a over here. It can cancel out to give me just a single a on top here. Okay, again, not quite the form in MF26. What we have is 1 over x squared plus a squared. And you guessed it, we're going to divide by a on both the left hand side and right hand side of the equation. And that gives us the 1 over a over here. That we see. Right, d dx of this equals to this, which also means that if you integrate this, then it becomes this, and the integral sign actually cancels off with this, so you actually get what you see in the MF26. Okay, so let me remove that because it looks really messy. Okay, now let's look at sine inverse. What's happening over there? Why is there no 1 over a? Well, we go through the same process. We're going to make a similar substitution. Okay, so actually it's the same step at the front. I'm not going to go through that. So when we d dx sine inverse u, then we get the derivative of sine inverse first, then du dx, again chain rule. Next, I made the substitution. U is equals to x over a. U squared is equals to x squared minus a squared. Du dx is 1 over a. Again, not quite the form we're looking for. We're looking for square root. For the denominator, we're looking for square root of a squared minus x squared. To make that happen, I need to multiply by a to the numerator and a to the denominator. So if we do that, we're going to get a in the numerator and square root of a squared minus x squared. Then you realize that this a can be cancelled with the 1 over a from du dx. So what you get is this. Okay, and that is the reason why sine inverse, right, in your standard results, right, there is no constant in front of the sine inverse, the integral. Okay, and we can attribute that to the square root sign over here. Yes, if you compare to a similar step on the tangent inverse working, we multiply by a squared to the top and bottom because there's no square root sign. Okay, because there's a square root sign here, we only multiply by a, and that single a cancel out with the 1 over a from our du dx chain rule. So that's why we don't have 1 over a. But on this side over here, we actually have an a square, right? So that's one more a more than the sine inverse sides, which results in the 1 over a here. Okay, so I hope I think this was quite a fun discussion question, and I hope this video can help someone else who's also wondering about the same question. I had fun making this. I hope you enjoyed watching as well. So until the next video, catch you on the flip-flop. Oops.